Welcome back from the ad break, and let's continue with our lesson. So now we are going to look at those application questions. Remember, we are working with functions and relationships. Let's look at our first question there. So our first question there says, fill in the flow diagram and represent this information in a table. Remember, we are looking at equivalent forms. So we want to see how a flow diagram and a table is going to represent the same function and relationship. So our flow diagram here has the input values on the one side, which is the left-hand side, and those input values are going to go through a rule and produce the output values. So the first input value there is 5, and when we multiply 5 by 9, we get our 45. So 5 multiplied by 9 is 45. And of course, when we add 7 to that 45, we will get an answer of 52. Now, when the input value is a 5, we got an output value of a 52. Then we move on to 10 as an input value. So 10 multiplied by 9 is a 90. And when we add 7 onto that, that is going to be 97. And then the last output value there is a 20. And then, the last input value there is a 20. We are going to multiply that 20 by 9, and that is going to give us 180. And when we add 7 on to that 180, we get an answer of 187. Let's go ahead and fill in our table from this flow diagram. So we've already completed our flow diagram, and we can see what the rule was with our flow diagram. The rule was that we multiply the input value by 9 and we add a 7. So our first input value there is a 1. So 1 multiplied by 9 is, of course, that 9 there. And when we add 7 to that, our answer is going to be a 16. So when the input value is 1, the output value is a 16. What about when the input value is a 2? We know that we have to multiply the 2 by 9, that gives us 18, and when we add that 7, that is going to give us a 25. What about when we multiply the 3 by 9? So when we multiply the 3 by 9, that is going to give us a 27. And when we add 7 onto that, our answer is a 34. Then we are going to multiply the 4 as our input value by 9. Well, 4 multiplied by 9, that is giving us a 36. And when we add 7 onto that 36, we know our answer is going to be a 43. What about when our input value is a 5? Well, we already have that on our flow diagram. We saw that our output value was a 52. When the input value was a 10, the output value was a 97. And lastly, when the input value is a 20, the output value was 187. And that is now our table filled out from this flow diagram. Now, how about we describe this rule in words? So when we describe this rule in words, we can see that the input value, So the input value is multiplied by 9. The input value is multiplied by 9. And after we multiply the input value by 9, then we are going to add 7 onto that. So then 7 is added to that product. So the input value is multiplied by 9, We didn't write that in. Since as well it's words, let's just write everything in words. So the input value is multiplied by 9 and 7 is added to that product. That would be this rule in words from our flow diagram, and of course we've seen from our table as well. Let's move on to the next question. So it says there, represent the following table as a flow diagram. So as we can see in our table, we have been given the input values, which of course we know is represented by the X, and the output values, which is represented there by the Y. So the input value being 1, the output value is a 4, input value being 2, the output value is a 9, the input value being a 3, the output value is a 14, input value being a 4, the output value is a 19, and of course the input value being a 5, the output value is a 24. So let us represent these values on a flow diagram. So a flow diagram, we know that the rule is the one that comes in the middle. So we can see that we have our input values and our output values. So input value, when the input value is a 1, how many input values do we have? 1, 2, 3, 4, 5. So let us provide space for all of these input values. So we have 1, 2, 3, 4, 5. And if you notice there, our input values are consecutive numbers. So our input values there are consecutive numbers. So what about our output values? And remember, our output values are represented by a Y, just like our input values are represented by an X. So the output values there, we will also have 5 of them. So we are going to have 4 as the first input value, 9 as the next input value, 14 as the next input value, then we have 19, and then we have our last input value, which is 24. Now looking at our flow diagram, is it complete? Of course it is not complete because we do not have a rule. Remember, a flow diagram must have a rule in the middle. So now that we have the input values and the output values, how can we find the rule? Well, since as well our input values are consecutive numbers, this actually means that these values are forming a pattern. So when we have 4 and 9 and 14 and 19 as our output values, because the input values are consecutive numbers, then that means that they form a pattern. It means we can use our knowledge that we learned in number patterns to find this rule. So we know that from 4 to 9, we are adding a 5. And from 9 to 14, yes, we are also adding a 5. And from 14 to 19, again, we are adding a 5. And what is that 5? That 5 is our our constant difference. That 5 is our constant difference. And once we have a constant difference, then we can definitely find that rule. Let's see how we are going to find this rule. Well, using our consecutive output values or our consecutive input values, we are going to say here, for us to find the output value, we know that it is going to be our constant difference multiplied by the input value, and of course we are going to add or subtract that constant value that we know we are going to add or subtract. So let's choose any of the output values as long as we use the corresponding input value to find our answer. So we are going to use input value of 2, which has an output value of 9. So 9 is the output value, which is in the place of the Y. And we know that the input value is going to be multiplied by 5. 5, remember, comes from that constant difference. So our input value here being 2, we know that 5 multiplied by 2 does not give us 9. And that's where we have to find that constant value that is added or subtracted. So 5 multiplied by 2 is a 10, and from that 10 we are just going to subtract 1 to get to our 9. Let's look with another input value and output value. We can take the input value of 3, which gave us an output value of 14. Now that 3 is going to be multiplied by 3, which gives us 15. But for us to move from 15 to 14, we are going to subtract 1, and that is going to give us our output value of 14. Now, what does this mean for our rule? We know that for our rule here, that our input value is first multiplied by 5, and then we subtract that 1. And that is our rule for this table. Now remember, when the input values are consecutive terms, then we can definitely find that rule, because those output values are actually forming a numeric pattern. Let's move on to our next question. Now our next question here says, fill in the flow diagram below and represent this information in a table. So we want to see how the equivalent form, how the a table can represent the same equivalent form as the table. So the flow diagram and the table would be representing the same relationship or the same function. So now we have that 2 as the input value. That 2 is going to be multiplied by 5. That would give us a 10. And when we add 6 onto that, that gives us our first output value, which is a 16. What about that 5? Now 5 is going to be multiplied by 5. That is going to give us a 25. And when we add 6 onto that, that is going to give us an output value of 31. What about when the input value is an x? Now when the input value is an x, of course we know that x multiplied by 5 will be our 5x. And if we add 6 onto that, that is going to be 5x plus that 6. And that immediately gives us our formula using those symbols there. Just using that rule helped us to find the formula if the input value there is an x. Let's fill out our table quickly. So with our input values being a 2, a 5, and an x, we can see that the output values were a 16 for the input value of 2, a 31 for the input value of 5, and a 5x plus 6 for the input value of that x. Looking at our last question there, it says a number is multiplied by 3 and 1 is subtracted from the product. So we are going to fill in that flow diagram from the rule above. So this is indicating us moving from that word representation to a flow diagram. So we can see that we've been told that a number is multiplied by 3. So that is the missing part of our formula. We are multiplying by that 3. So 2 multiplied by 3 is 6. And when we subtract 1, we get that output value of a 5. Then when we say 7 multiplied by 3, we know that is the 21. And when we subtract 1, that is going to give us an output value of 20. And then lastly, we do not know what the input value is, but we can see that we have been given an output value of that 35. So when we take that 35 and apply the additive inverse, so the additive inverse of -1 is a +1. And again, the multiplicative inverse of a multiply by 3 will be a divide by 3, which is of course the same as multiplying by 1/3. So we are going to say 35 plus 1, remember, because we are moving backwards. So we're going to say 35 plus 1, and that of course gives us 36. Then from 36, we are going to divide by 3. Remember, we are dividing by 3 because that is the multiplicative inverse of a 3. So we are going to say 36 divided by 3. And of course, that gives us an answer of 12, which means the input value there was a 12. Now, when we go on to B, it says, write down the equation for this flow diagram. Now, remember, an equation is just two expressions that are equal to each other. So we are going to use our variables to write down an equation or a formula for this flow diagram. We know that to get the output value, we are going to take the input value, and this input value is multiplied by 3, and from that product, we are going to subtract 1. So that means our formula or equation is going to be 3x minus 1. Now, can we use these values to represent them in a table? Let's conclude with this question here. So we are still working with number 5. We're still working with a number being multiplied by 3 and 1 being subtracted from that product. So C there says, from the equation, do you remember what our equation was? Our equation was y is equals to 3x minus 1. So from that equation, fill in the table using the first 6 multiples of 3 as the input values. So as we can see there, our table has not been written, or the input values have not been written in there, but we are told that we need to use the first 6 multiples of 3. Now, do you know what the multiples of 3 are? Of course you do. So we are going to use the first 6 multiples of 3. So that is our 3, 6, our 9, our 12, our 15, and lastly our 18. So those are our input values. And when we use those input values, remember, we are multiplying each input value by 3 and subtracting 1. So 3 multiplied by 3, that is going to be a 9. When we subtract 1, our answer is going to be an 8. What about 6 multiplied by 3? That is 18, and when we subtract 1 from that answer, that is going to be a 17. 9 multiplied by 3, that is a 27, and when we subtract 1, our answer is going to be a 26. What about 12 multiplied by 3? Now 12 multiplied by 3 is a 36, and when we subtract 1 from there, that is going to be a 35. Then when we say 15 multiplied by 3, 15 multiplied by 3 is 45, and when we subtract 1, we are going to be left with a 44. And lastly, we have 18 multiplied by 3. Now 18 multiplied by 3, do you know what the answer is there? Yes, it is a 54. And of course, when we subtract 1 from that answer, we are going to get a result or an output value of a 53. Let's quickly go to an ad break, and then we'll see you just now.